All right, we are going to have a quick look at a CF example for finding the sum of a geometric series. So the question says, when dropped, a ball takes 1 second to hit the ground. It then takes 90% of this time to rebound to its new height, and this continues until the ball comes to rest. Determine how long it takes for the ball to come to rest. So I think it's useful to draw a bit of a picture to see what's happening here. The ball is starting at a height and it drops down. That takes 1 second. It then bounces back up. It's obviously going to bounce back up in the exact same place, but I'm going to draw it to the side here so I can see what's happening. And it bounces up to 90% of 1 second, so 0.9 seconds it takes to bounce up. And then it bounces back down from that same height of 0.9 seconds. Then it bounces back up again to 90% of 0.9 seconds, so 0.9 seconds squared, and back down 0.9 seconds squared, and so on and so forth. And that height is getting smaller and smaller, and it continues to rebound like that. Okay, so we can see that it is a converging series with the R ratio is going to be 0.9 each time the height is getting multiplied by 0.9. So it says we need to find how long it's going to take for the ball to come to rest. When we think about what's actually happening, it's very useful to try and write down what the series looks like. So we've got T1 is 1 plus, then it needs to go up again, so 0.9. Then it goes down from this height, so 0.9 again to the ground. It goes up to 0.9 squared, back down, and so on. Okay, so it doesn't really look like what we would expect for a geometric series, but if we tidy it up a little bit, we will be able to see how we can apply our learning to this question. So 1 plus, now I'm going to group these together, so we've got 2 times 0.9 plus 2 times 0.9 squared plus 2 times 0.9 cubed, and that is going to continue on. I'm going to just look at this, well, we've got T1. Technically there's 1 second here, but I'm actually going to take that out and ignore it for the purpose of my calculations, because if I tried to use this as a series as it is right now, I would be looking to find the common ratio of R, and I would look at the second term divided by the first term. And I would test again by doing the third term divided by the second term. And you see that you actually get different answers there when you're setting that up. So that doesn't suit our requirements for a geometric series. So I'm going to keep this one separate, and we'll just add it on at the end to find out how long it takes to get to rest. The other thing I'm going to do is I notice that I've got 2's in front of all of these. That's factoring in the time going down and then up, but it's repeating that process. So I've got 1 plus 2, and then it's all going to be outside of 0.9 plus 0.9 squared plus 0.9 cubed, etc. And this portion inside those brackets, that portion is really going to be the bit that we're interested in to make our series work. So if I just consider inside these brackets here, I've got T1 equals 0.9, and I've got R. I can see that what's happening is I'm just multiplying each term by 0.9. So if I want to find the sum of that section, that series there, it's going to be T1 over 1 minus R, which is 0.9 over 1 minus 0.9, which is 0.9 over 0.1, or just 9. So that whole green section there can be simplified to, OneNote has crashed. That whole green section there can be simplified to positive 9. And so we're almost done. Now we would just go back and substitute in to find the value of the whole time, and we get 1 plus 18. So it is going to take 19 seconds to get that ball to rest. Now, it doesn't really look like geometric series question when you look at it initially. So that's probably why I've categorized it as a CF question instead of an SF question, because we had to do a little bit of manipulation to get it into a CF, sorry, into a geometric series that we're a bit more familiar with.